Okay, above we have started to investigate the uncertainty in US election, particularly the individual ballots, how uncertainty the population votes and how uncertainty the subpopulation votes. And in the next, we'll try to apply the same kind of knowledge to build some predictive models for the data. But before that, let us do some aggregation. So instead of trying to predict individual votes, let's say we do the prediction for the votes, for the voting results in individual counties. Here is a why question. This is a why question for you. I will suggest to pause here and contemplate for maybe 30 seconds. Why we do not want to predict the individual votes? Well, because we can't. Remember the most important essential factors for applying whatever kind of statistical learning methods. First of all, we are doing data analytics. We need to have data to be in business. Probably there is not very large scale to the individual level details collection of data. We simply do not know what are the votes, what are the votes for individual Americans. So we only have the collective data for the counties. So we'd rather to get a coarser, greater granularity in the analytics and consider the counties rather than individual persons. That is only because after we have built the models, we have data to fit to the model, to train the model to the data, and to evaluate whether the model is working. Otherwise, we just purely playing with our hypotheses. Okay. So I built some targets. We will not use all of them. I will only use this guy. The one of the target is to determine whether the Republicans won the 2016 at each places. In each places. Well, it gives some warnings about whether you take the view or the copy of that frame. But I think we do not need to worry about that. So yeah, we can have a look at this. We can check whether the information has been built here. Let's execute that. Well, you can see we have the Boolean values for each places, and let's examine some statistics of these values. Though you see, Republicans won a lot of places, and what we will reckon from this, yeah, maybe Republicans take a lot of places, but they have a smaller population, and therefore, when it comes to the popular vote, you have mostly half and half. Okay, but this is the unbalanced data we need to take care of, and we repeat whatever what we have done before and calculate the entropy. The entropy, well, I think I've made an error here. I need to put log 2 here, but it really does not matter too much if you use different bases for the entropy. Of course, it has some consequence in how you can interpret the entropy number you got whether it's using bits or other kind of measurement units of the information. But for different kind of the basis, basically the measurement itself can be compared to each other. So, well, okay, following the same strategy, let us say if we look at the uncertainty in each of the subpopulation and see whether the extra information can help us to reduce the uncertainty of the distribution of whether the Republican won in 2016 in different counties, such kind of a population. So let's continue. Also, well, I need to change this into log 2, I summarize this into the entropy computation and reporting in a function, okay, to facilitate treating. And let us split the data with respect to different states. Let's see, how about if we know the knowledge of different counties belonging to, well, located in different states. Such information can help us to reduce the uncertainty of the voting outcome in 2016. So let's see if our data contains very nice information about the statistics, the information about states. Yes, Texas has 2,254 counties, Georgia, Virginia, so on and so forth. So the numbers represent how many records in our table, because each record in the table corresponds to an individual county. So these are the counties with valid data in each of the states. Okay, we will take use of this this information of states to consider the individual subpopulation of the counties, these 200 counties. How about the vote outcome in these 254 counties, and how about the voting outcome of these 159 counties, so on and so forth, and compute the individual uncertainty in each of them and take a weighted sum and consider that as how much uncertainty we have reduced from the total uncertainty about the voting outcome. Okay, let's do that. So basically, okay, let's maybe explain this code a little bit with more details. The states, as we have extracted from the data table, is a dictionary-like object. For that, we can iterate over its items. So the K will represent the name of state, and the V represents the number of times that state appear in the table. That means the number of counties in the state. So, right, let's do this. Okay, you can see this. Well, then for each of that, we would take the subpopulation of the corresponding counties in the state and consider using the function of examine the entropy to examine this subpopulation of the counties. Okay, so how about if we print out the first state, Texas, and the number of counties, and then we break. Okay, now our K is Texas. Sure. Then what we will do is to take the population of Texas. Now we will have the subpopulation of counties in Texas. Okay, all Texas counties. And we can use the exam counties to examine the entropy in this subpopulation. Sure. Okay. In this for loop, we will do that for each county, and so we want it keep quiet. We set verbose is false, so it will be quieter and just report, shut up and report the final outcome. Okay, good. So we do this, and here, after we get this entropy of this particular texts, we will apply this entropy, factor this using the total number of counties in this subpopulation, and we accumulate this into a total quantity, and the last we will compute the weighted sum. Okay, so look, we have 200 something times this, and the next one is Virginia, I think. No, Georgia. Then we will have 159. That, say, Georgia. How to spell that? Just copy that. Sorry for that. Don't worry about this printout. Okay, so this is entropy for Georgia, and this will be multiplied by the 100 something counties and accumulate to this. Okay, so we do this accumulation, a weighted accumulation, and then we divide the total accumulated number with the number of counties and get overall average entropy with knowing the states. Let's see. So these are different states, and the result entropy, this number times this one, accumulation, this time, and we do this all sum up, and eventually we have the weighted sum of the entropies is this, and compare this to the original total entropy of this. Look, we get a reduction in uncertainty. Okay, the idea is to apply this, but using different criteria of investigation. Now we use the information of state. How about using other kind of information? Let's try in the next video.